Well, good afternoon, everyone. So I have the slightly challenging task of trying to, in 10 minutes, answer this fairly fundamental question of whether one particular set of technologies with a wonderful name of 3D printing is going to lead to a new industrial revolution. That's quite a big thing to do in 9.5 minutes, but I'll give it a go. So this is all about something very important, and I'm going to try by the end to lead to one simple, direct answer to that question. But before we do that, we've got to take it back a level, or up a level, depending how you look at it. And that's to say, to ask a very basic question. And that very basic question is, how do we make stuff? How do we go from materials into something that we want to use, to buy, to consume in some way? And this is going to be a little bit of Manufacturing 101. Some of you will know this, others maybe not, but we'll put it into 4 simple areas. The first way we make stuff, we go from raw materials into a thing, is what's called through subtractive processes. So you're probably getting a bit worried now, thinking, oh no, the engineer's going to give a really tedious talk. Well, it may be, but to try and bring it to life and link engineering with art, here is an example of a subtractively manufactured thing. Okay, there was a big old block of marble, and material was removed from that in apparently quite an artistic way to create that beautiful statue. In fact, the subtraction went on a bit too far there. There are a few bits missing. The next type of manufacturing is called forming, where you take your block of material, whatever it may be, and you apply force to it to change its shape. And many things in the world are made that way. My personal favourite is this one here. There is a nicely formed set of objects, Wallace and Gromit. The third type of technology for making things is casting, where you take your raw material in solid form, you make it liquid, and then you put it into some sort of shaping device, a mould, and you make the object that you want. A nice example of that is the chocolate bunny. Now, it's used for many other things as well, and I could talk for hours about the way these are done, but there are 3 simple examples of subtractive, forming, and casting. But there is another type of manufacturing, and that's called additive, and that's where you have nothing to begin with, and you take your material and you just put the material where you want it to be until you have the object that you want. And additive manufacturing has been around for a very long time, relatively speaking, but it's had a fantastic renaissance because it's been rebadged with the great name 3D printing. And for those who don't know what 3D printing is, here's a short video that explains what it is. So you'll see the basic principles at work here. There's a build plate, you have an electronic file, and it puts down the material exactly where you want it and only where you want it. So there's no waste, there's no tooling, there's no cutting. Now this is slightly sped up, but there we have what I've just realised, of course, is the logo for TEDxOxBridge, which you've seen in all your brochures, and all the helpers' t-shirts have this on. It's almost like this was planned. So there it is. That's a 3D printed object. You could go, well, great. So we now know there are 4 ways of making stuff. Frankly, so what? Right, moving on. The so what is because what can you do with this that's really, really powerful? So to make things, before you make a final object, you often want to make what's called a prototype. So 3D printing is brilliant for prototyping, and specifically rapid prototyping, doing it very quickly. So there are some of our students working in our rapid prototyping lab, making an object that's part of a bigger system they're trying to build. So they can make this very quickly before they build a final one. That's pretty good, and it really helps manufacturing. But it's even better, because you also have the ability to make final parts with 3D printed. It's not just about plastic, you can do it with metal as well. And so here is an object that has been 3D printed, and you might not recognize it necessarily, but if I just draw this picture, it's that bit of that jet engine which is now flying on that aircraft there. They're actually making parts of aircraft engines now using 3D printing, and these parts are lighter, more effective at certain things. They just have 3D printing gives you the ability to do things much better that you couldn't do otherwise. That's a pretty good thing for a technology to do. It gets even better, though, because one of the great features of 3D printing is the way in which it can be used for customization. In other words, as every single object you make on a 3D printer can be different, you can have this wonderful idea of moving towards mass customization. And 2 quick examples of what I mean by this. So, prosthetics. Prosthetics tend to be either expensive and very good, or cheap and not very good. And if you're a child who needs some sort of prosthetic device to help them live a full life, then it gets quite expensive and quite difficult. With 3D printing, you can do amazing things. So on the left there, you have little Liam, who's born with no fingers on one hand. And on the right, your right there, we have Emma, who has a condition which means that her joints are very stiff and her muscles are very weak. But thanks to 3D printing, you can produce very low-cost prosthetic devices that allow them to move and pick things up and do things, and as they grow, you just print a slightly larger one. It's fantastic for that. So for those reasons alone, I reckon 3D printing is doing something quite amazing. But there's more. A little bit philosophical here. How do we make stuff normally? Well, far away at the moment, there are many big factories where stuff is made. And factories tend to be big because you want them to be highly efficient. And you put them where the costs are most effective. And then you take the stuff out of the factory and you put it on a boat, not like that, but something like that. You put it on a truck when it gets to the harbour. You take it to the depot or the shop. You then buy it and you're very happy with what you've got, hopefully. So production and consumption have been separated. They're very, very far removed from each other. 3D printing gives us a chance to do something slightly different, which is to combine these two things by removing that, and that. And so we have a much closer link between production and consumption. So the picture to represent that would be this. You actually make the production system, the 3D printer, locally, smaller, more accessible, more customizable, more usable, and so the production and consumption are merged together. You could go, well, why would you want to do that? Well, here's a few reasons. So, at the moment, if you want something, a spare part or a tool or, I don't know, a chocolate bar or something, you have that delivered to you and you don't really care where it's made. Now, if you happen to live in a place like this, getting the things you want is quite tricky because you have to have one of these to get that thing you want all the way up there. Okay? And that's fine. These rockets are getting cheaper and better, and it's fine to have things delivered into space, but it's still a bit risky and still a bit expensive. So what they've done is to say, why don't we squish these two things of production and consumption together? And so, if you look now, there is an astronaut on the International Space Station who has 3D printed a particular component, a little wrench there, that he needs. That may not be very exciting, making a little bit of plastic like that, but it indicates a fundamental change in how we think about where we make things and where we use things and how they can be closer together. But again, every probably 1 in 10 TED Talks has to talk about NASA and say, well, NASA do it this way, so that's fantastic. And people go, yeah, but the rest of the world doesn't. Well, here we go. Here is another way that's perhaps a little more relevant to more people, which is in disaster zones. Things go badly wrong in disaster zones. People get displaced and they need stuff. Stuff has to be shipped to the right place, but there are all sorts of issues to do with how aid agencies get materials and goods to where they're needed. So here is a great picture. That is a camp for displaced people after the Nepal earthquake. And there are lots of little things that are needed that are actually very hard to get. For example, if a pipeline in a town has been broken, water's pouring out, you want to connect that pipe together again, but perhaps you need to connect a big plastic pipe to a little plastic pipe, or a bigger metal pipe to a plastic pipe. To connect those two things is very difficult, and to stop the leakage. So what these engineers from this great organisation called Field Ready have done is to take 3D printers to places like this, and you print the object that you want right there. They may only need one, but the cost and complexity of trying to get that sourced from somewhere else and shipped all the way there would take far too long and just be no good at all. So there it is, 3D printer on a Land Rover bonnet being printed outside a camp in Nepal. So there's more though, because not only do you start to say, well, we start to put these printers close to where people need stuff, we can now also start to say, well, hang on, someone else might go, I like what you've printed there, can I have that too? Someone else with another printer might say, well, I've got a different kind of printer that can do that a bit quicker, a bit better, a bit faster. Maybe someone else has that same offer as well, but perhaps there's another person who needs something made as well. So suddenly you start to see this network forming where people are connecting on a local basis between production and consumption in this community approach. And so you might say, well, that sounds like a nice dream to have, but of course it is happening. Organisations like 3D Hubs, there we go, 30,000 3D printing services all connected together to allow people to access 3D printers, which gives over 1 billion people access to 3D printing technology, thanks to the connectivity between all these small local hubs. It goes on. There's more. And so we start to see things like these, the renaissance of the maker movement. In Cambridge, we've got Cambridge Makespace, where people go to make things, to repair things, to come up with new ways of connecting with physical objects and being involved in that process. And that's, you go, well, okay, 3D printers and makespaces all sounds very nice. Is this going to do anything? Well, colleagues at the Royal College of Art, running a project called Future Makespaces, are doing exactly this. They're saying these 3D printers put into makespaces, connected together, can do something amazing. and they're looking at the top left there, how the make spaces are configured, bottom left there, how they fit into local communities, top right, how it connects to the broader digital environment, and bottom right there, how this fits and affects things on a national or international scale as well. So it really is doing something amazing. And if that wasn't enough, it goes even further, because the UK has a chronic shortage of engineers. Of course we should have more engineers. Engineers make the world better. Slightly biased, but I'll say that anyway. But we're not getting enough of them. One of the problems is having lots of kids who've grown up highly competent at using bits of metal with a glass sheet on the front, and they can navigate this virtual world way better than my generation and perhaps your generation can. So what 3D printing offers is another solution to another problem, which is to connect younger people today from the virtual world, connecting it to the physical world. And look what's going on there. You've got all these school kids working on their screens where they're very comfortable, directly connected to a 3D printer, to make something that will appear before their very eyes. It's connecting the virtual and the physical to give people a real understanding of how important making things and engineering is. So, coming to a close, I promised at the beginning I would give you a nice, simple, unambiguous answer to that question there. And I can hope you'll see from the story I've told, the layers we've built up there, that there is a very clear, simple answer to that question, and that is maybe. Because we don't know enough about this yet. And what I'd leave with you as a final message is that if you'd like to know more about what's going on with 3D printing and how it might affect our lives in the future, please have a chat with me afterwards or go to that website there. Thank you very much. Thank you.